Hi, this is Avin. Welcome to my channel Tricks World. In this video, I'm going to reveal how the mathematicians and ancient scientists were able to give so many identities, so many theorems, so many equations and formulae still we are using in our school and colleges. The question comes to our mind, the ancient mathematicians were godly gifted? To answer this question, it is very difficult, but one thing it is clear that the ancient mathematicians or scientists, they were doing so many experiments repeatedly, and when they get same consistent repeating results, they were putting them into in a form of an equation or in the form of a theorem or identity. Today I'm gonna give you algebraic as well as geometrical proofs for most widely used identities in school and colleges, that is a plus b whole bracket square equal to a square plus 2ab plus b square, and a minus b whole bracket square equal to a square minus 2ab plus b square. First I give algebraic proof for second identity, a minus b whole bracket square equal to a square minus 2ab plus b square. Then I give the geometrical proof for this identity because it is more complicated to explain. So I take the second identity to prove first. We have a minus b whole bracket square. If we have m square, we can write m 2 times. In the same way, here we have a minus b whole bracket square, so we can write a minus b 2 times. Now, let us multiply Now I'll take minus b and I'll multiply to second bracket a minus b. A into a square minus a into b, ab minus b into a, ba. If we write alphabetically, it will be ab minus into minus plus b into b, b square. Now a square, we have minus ab 2 times, so minus 2ab plus b square. So this is the proof for a minus b whole bracket square, that is first term square minus 2 times of product of first and second terms plus second term square. Now let us see the geometrical proof for this identity. Here we go. Let me give geometrical proof for identity a minus b whole bracket square. Consider a be the any quantity. A be the any quantity. This is a. Now from a I am going to subtract quantity b. This much is the quantity b. I am going to subtract. Therefore, this quantity becomes a minus b. This quantity becomes a minus b. Now, let us draw a square by taking the side a. The square of side a. This is the square of side A. Each side is of length A. Now, let us draw possible quadrilaterals in this square. Here is one quadrilateral possible. And here, if we take A minus B length, this is A and if we subtract quantity b here, therefore this length is a minus b. Here these are the three quadrilaterals we get. What is the length of sides of this quadrilateral? This is a minus b, means this is also a minus b. This is a minus b, means this side is also a minus b. Then this quadrilateral has all four sides same. Therefore, this is a square. Therefore, area of this square is a minus b bracket square. Let us consider this quadrilateral. Area of quadrilateral is nothing but length into breadth. Here length is b, breadth is a, therefore area of this quadrilateral is AB. Now let us see the area of this quadrilateral. Its length is b and its breadth is, this is nothing but a minus b. Therefore, the area of this quadrilateral is b into bracket a minus b. We want area of this square. We want a minus b bracket square. How can we get area of a minus b bracket square? When we subtract these two areas from the area of this big square. I repeat, we want area of a minus b whole bracket square, means we want this area. How can we get this area? We get this area when we subtract area of this rectangle and area of this rectangle from total square. Let us do it. I write a minus b whole bracket square. We want this area. How can we get? We have to subtract these two areas from the area of square. What is the area of this square? A square. Area of this complete square is a square minus area of this rectangle is AB minus area of this rectangle is b into a minus b. Now let us open these brackets, a square minus ab. Now b into a is minus ab. I have written alphabetically. Minus into minus what? Plus b square. That is equal to a square minus ab and minus 2ab plus b square. In this way, we have proved geometrically identity a minus b whole bracket square equal to a square minus 2ab plus b square. Now, let us try to prove a plus b whole bracket square equal to a square plus 2ab plus b square. Here we go. Let us see algebraic proof for identity a plus b whole bracket square. We start with a plus b whole bracket square. This means we have to write this bracket two times. That is a plus b into another bracket a plus b. Let us simplify this. We have to take first term, we have to multiply to the second bracket, that is a into bracket a plus b. We have to take second term and we have to multiply to the second bracket, that is a plus b. Now a into a square plus a into b ab plus b into a ba. Alphabetically if we write, that becomes AB plus b into b square. A square. We have similar quantities AB two times, so we have to write 2 times AB plus b square. In this way, we can prove a plus b whole bracket square equal to first term square plus 2 times product of first and second term plus second term square. Now let us see the geometrical proof for this identity. Here we go. Let me give geometrical proof for this identity a plus b bracket square. Consider a is a quantity. For this quantity we are going to add, this is a quantity, for this quantity we are going to add say quantity b. The total length of this side becomes a plus b. What we want? A plus b bracket square. That means we want square. Therefore, let us draw a square by taking the length a plus b. Up to here it is a and here this is b. We are drawing a square by taking this is the side a and this side is up to this it is b. So what is the area of this square? That is a plus b bracket square, because the length of each side is a plus b. The length of this side is a plus b. The length of this side is a plus b. So the area of this square is a plus b whole bracket square. Area of this is a plus b whole bracket square. Now let us divide this square into small possible quadrilaterals. Here we can draw 3 quadrilaterals. This is one and this is another one and this is one. If we consider this quadrilateral, its side is a. Therefore this is a square. Therefore area of this square is a square. If we consider this quadrilateral, its length is b, breadth is a, therefore length and breadth are different, therefore it is a rectangle. Area of rectangle is nothing but length into breadth. Therefore area of this rectangle is a into b. Now here the length is b and breadth is a plus b. The breadth is a plus b. Therefore area of this triangle is breadth length into breadth, that is b into bracket a plus b. Now what we want? We want area of this complete square, that is a plus b bracket square. What we want? We want the area of this complete square, that is a plus b whole bracket square is equal to this area. It is made up of 3 quadrilaterals. This is first, second, third. What is the area of this quadrilateral? A square plus what is the area of this quadrilateral? AB. What is the area of this quadrilateral? B into bracket A plus B. Let us simplify. A square plus AB plus B into A, AB plus in B into B, B square. Now A square, here we have plus B. We have totally 2AB plus B square. In this way, we have proved that identity A plus B whole bracket square equal to A square plus 2AB plus B square. In this video, I have tried to show you how our mathematicians were successfully proved the identities a plus b whole bracket square and a minus b whole bracket square algebraically and with geometrical proofs. I am thankful to YouTube and millions of YouTube viewers. I hope you have enjoyed this video, and please subscribe, press the bell icon, share the video. In coming videos, I will bring you few more geometrical identities with proofs and with tricks. Please subscribe my channel Tricks World.